Good afternoon, students. In the last class, we discussed about the catalysis theory. Okay, in that mechanism of the enzyme catalysis, how the catalysis process takes place on the solids in presence of enzymes. And also, we also studied about the catalysis and its types, catalyst and its types, effects of some temperature, pressure, those variables on the catalysis, and also mechanism of the catalysis. One is absorption theory of catalysis, another one absorption or a product formation or a mechanism of enzyme catalysis. We are all studied these in this catalysis. That is what the second feature of surface chemistry. First one is absorption, second one is catalysis. So the third feature of the surface chemistry is colloids. Okay, colloids. What are colloids? What is the role of colloids in the surface chemistry, or what is the role of surface chemistry in the formation of colloids? Everything we are going to study in this colloids. Okay. Here types of colloids are there. Okay. In that types of colloids, their nature is there, their difference is there. Which solutions are called as colloid is there. Okay. So the soap action is especially due to this colloidal property. How the soap action takes place. What are the properties of colloids? What are the methods of preparation of colloids? Chemical methods usually. Those are all we are going to study in this colloids. Okay. So students, remember. So if you want to say anything to explain surface chemistry means at least we need two components. To explain surface chemistry, we need at least two components. One which turn adsorbent and adsorbate. You know them. Adsorbent is the one which gives surface for adsorbate. Adsorbate means one which settle down on the surface. Adsorbent. So students, this colloids is I'll take three examples. Okay, one is sugar solution. And the second one is soil water mixture. Mud, you may say. Okay, mud. Okay, and the third one is ink. Third one is ink. Okay, so students, here the best example for this sugar solution, what are this sugar solution, what is this soil, and what is this ink? Ink is there, milk is there, etc. So many. Later I will explain what is ink, what is how they are different. This is also a solution, this is also a solution, this is also a solution. But in this, here sugar is dissolved in water. Sugar in water. Correct? Next, here this one is soil in water, and this one is dye in water. What it is? This one. Dye in water. Okay. So students, listen. When you dissolve that, what is that? Sugar solution. Okay. Sugar solution means sugar is dissolved in water. When we dissolve sugar in water means it completely dissolves. It forms a uniform solution. Understand? When sugar is dissolved in water. Understand? When the sugar is dissolved in water, they form a transparent uniform solution. Okay? When the sugar is dissolved in solution, water, they form transparent solution. Correct? If you mix sand or soil in water, mix is it form a transparent solution? Transparent solution of course we can easily see the soil particles in the water. It is non-transparent. Okay, this one is transparent, this one is non-transparent. In this, we can easily say, if we keep this solution for certain time, the soil particles are settled down at the bottom of the container. Okay, if soil is mixed with water, if we keep that solution for a certain minutes without disturbing, then all the soil particles are settled down at bottom of the container. Means solvent will separate out and solute will separate out. Understand? Here it is not transparent and we can easily see these particles. And next one is ink and milk. So in milk, you know, proteins are there, vitamins are there, everything are there. Protein is also there, calcium, metals are also there, vitamins are also there. Even though it is simply look like a white color liquid. Understand? Simply look like a white color liquid. In ink, blue color ink. What is it? Okay, this black color ink also assumed. So listen, in this ink, okay, so it is blue in color, liquid in state, means ink, that is organic dye, that is dissolved in water. We cannot distinguish. Of course, we can see a complete solution is blue in color. We cannot distinguish water, we cannot distinguish dye. Understand? So this is not transparent, but it is uniform. The whole concentration is uniform, but it is not transparent. Understand? Here, it is not transparent and not uniform. This one is transparent as well as uniform. Uniform concentration. Understand? So this is not transparent. May be transparent, may not be transparent. I am not telling. It is always not transparent. May or may not. May or may not transparent. Okay, and of course it has uniform concentration. For this example, I am telling ink, milk. Okay, so students, here what happens? Why this one become transparent means because here the sugar solution in which sugar is dissolved in water, it is transparent because the size of the sugar molecule is 10 to the power of minus 9 meter. That means 1 nanometer. Understand? It is 10 to the power of minus 9 meter. That is 1 nanometer. That's why it is very smaller in size. So that is easily dissolved in water. It is very minute. That's why we cannot see easily. Understand? Not even in microscope. And listen, students, if once that solute is this sugar is dissolved in water means we cannot separate it by filtration. Okay? So if we filter that using any filter paper or any physical separation cannot be takes place here. Understand? Okay? This is one thing. It cannot be separated by filtration. Here, the soil in water. Okay, soil in water. It cannot dissolve in water. It is just dispersed. It is just mixed with water, but it is not dissolved in water. Mixed up and the dissolution, there is a difference. If sugar is dissolved in water, it looks like water only. Means sugar is completely dissolved in water. So if soil is dissolved in water, so not dissolved, soil is mixed up with water, it cannot dissolve. It is only dispersed. Understand? Dispersed means mix up. Okay? Mix up with water. So this is 1000 nanometer in size. 1000 nanometer means 10 to the power of minus 6 meter. Here the difference, you know, 10 raised to minus 9 meter, here 10 raised to minus 6 meter. Okay? This is 10 raised to minus 9 meter or 1 nanometer. This is 1000 nanometer. This is called as what? Suspension. This is called as suspension. So students, this one is called as true solution or crystalline. True solution or crystalline. This one is called as suspension. ವಾಟರ್ ಸಸ್ಪೆನ್ಷನ್, ಏರ್ ಸಸ್ಪೆನ್ಷನ್, ಓರಲ್ ಸಸ್ಪೆನ್ಷನ್. ನಿಮಗೆ ಗೊತ್ತಲ್ವಾ ಟಾನಿಕ್ ಏನಂತಾರೆ? ಚಿಕ್ಕ ಮಕ್ಕಳಿಗೆ ಕೊಡ್ತಾರಲ್ವಾ ಟಾನಿಕ್, ಅದನ್ನ ಓರಲ್ ಸಸ್ಪೆನ್ಷನ್ ಅಂತಾರೆ. ಕರೆಕ್ಟ್ ತಾನೆ? ಓರಲ್ ಸಸ್ಪೆನ್ಷನ್ ಅಂತ ಯಾಕೆ ಹೇಳ್ತಾರೆ? ಬಿಕಾಸ್ ಅಂದ್ರೆ ನಾವು ಅದನ್ನ ಒಳಗಡೆ ಅಂದ್ರೆ ಕುಡಿಸ್ತೀವಲ್ವಾ ಮಕ್ಕಳಿಗೆ ಥ್ರೂ ಮೌತ್, ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಓರಲ್. ವೈ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಅ ಸಸ್ಪೆನ್ಷನ್ ಮೀನ್ಸ್ that solid, what is the drug, is dissolved in water. They form a suspension. Suspension means they are not dissolved. Color irutte tane yavudu syrups kodtaralva tonic, adu color irutte. So those are called as oral suspension. The reason is the drug which are they are going to used, they are not dissolved, they are just dispersed. Understand? Later I say what is dispersion. That is just a mixing up of any solute in the solvent. Understand? Next one is this colloids. So students, the size of the colloids is in between 10 raised to minus 9 meter to 10 to the power of minus 6 meter. Means 1 nanometer to 1000 nanometer. If the size of the solute particle is in between these two, then that is called as colloid. If it is less than 1 nanometer or is equal to 1 nanometer, then it is crystalline. If it is greater than 1000 nanometer or equal to 1000 nanometer, then it is suspension. If the size of the particle is in between 1 nanometer and 1000 nanometer, then it is crystalline. These crystalline are simply uniformly distributed throughout the solution. We cannot see them easily. Here we cannot see them. Here we can see them by our naked eyes. Here we cannot see them by our naked eyes, but we can see them in the microscope. Understand? The particle size is comparatively more to crystalline, less to suspension. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ವಾ? ಮಿಲ್ಕ್ ಅಲ್ಲಿ ಏನೇನಿದೆ ಅಂತ ನಾವು ಬೈ ನೇಕೆಡ್ ಐ ನಮಗೆ ಗೊತ್ತಾಗೋದಿಲ್ಲ, ಬಟ್ ನಾವು ಅದನ್ನ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲಿ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. ಅರ್ಥ ಆಗ್ತಿದೆ? ಇಂಕ್ ಅಲ್ಲಿ ಇಂಕ್ ಇದೆ. ಸೊ ಇಂಕ್ ಅನ್ನ ನಾವು ಥ್ರೂ ನೋಡಿದ್ರೆ ನಮಗೆ ಅಫ್ಕೋರ್ಸ್ ಬ್ಲೂ ಕಲರ್, ಬ್ಲಾಕ್ ಕಲರ್, ರೆಡ್ ಕಲರ್ ಕಾಣಿಸುತ್ತೆ ಡೈ. ಬಟ್ ಅದನ್ನ ಮೈಕ್ರೋಸ್ಕೋಪ್ ಅಲ್ಲಿ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ನೋಡಿದ್ರೆ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಡಿಸ್ಟಿಂಗ್ವಿಶ್ ದ ಪಾರ್ಟಿಕಲ್ಸ್. ಅರ್ಥ ಆಗ್ತಿದೆಯಲ್ಲ? ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ದ solution types: crystallites are true solution, suspension, and this colloids based on the size of the particles. So students, we will discuss about the differences between these three. Understand? Differences between these. Okay, so in this, first one is crystallites, next one is colloids, and the last one is suspension. So students, first one is size. Here the size is less than 1 nanometer, less than 1 nanometer, and this is in between 1 to 1000 nanometer, between 1 to 1000 nanometer. This one is greater than 1000 nanometer. This one is more than or greater than 1000 nanometer. Size is less than 1 nanometer. If you have doubt, don't understand, you completely write less than 1 nanometer. This one is between 1 to 1000 nanometer. More than 1000 nanometer. That is the first difference. Particle size. Okay, so the second one is the movement of the particle in the crystalline is fast. The movement of the particles in the crystalline is fast. Means sugar solution is there, it is very small in size, If we shake, we cannot see the movement also because it is so fast. Okay, so next here, they move, particles move slowly. Particle moves slowly, and here there is no movement. There is no movement. This is the second difference. Okay. Next. Third one, it is a homogeneous mixture. It is a homogeneous mixture. This is heterogeneous. This is also heterogeneous. You just have mixture. This one is homogeneous mixture, heterogeneous mixture, heterogeneous mixture. Understand? Because as I told you, we can see them. Understand? Homogeneous means throughout, as I told you, this is a heterogeneous mixture means throughout the solution there is no uniform concentration. Sometimes in milk it is uniform concentration. In ink it is uniform concentration. But in soap it is not uniform concentration. Understand? They may or may not be uniform, but this is called as heterogeneous mixture. There is a separate layer for solute as well as solvent. Understand? Later I will explain. Next action on light. So the transmit light. The transmit light. Next. So they scatter the light. This one, it transmits the light. This one is scatters the light and it doesn't scatter the light. So the scattering of light is called as students Tyndall effect, which is very important for 2 marks. Later I will explain in the properties. Okay, this colloid shows Tyndall effect, that is scattering of light. That is very important for 2 marks. Next, here, particle size are invisible. Particle size are invisible. Next, it is also invisible but visible in microscope, or visible but detected by scattering of light. Detected by scattering of light. And here they are visible at least under microscope. They are visible at least under microscope. Answer illa andru at least microscope allandru answer. Okay na? These are all the difference between crystalline, colloid and suspension. In that we are going to study most preferably about colloids only. Okay? So in the colloid students, dispersion medium we are going to use dispersion medium and dispersed phase. What is the dispersion medium and dispersed phase? I'll explain. Okay? So let's just rub this. So students, here in this colloids, the R1 terms we are going to use this, that is dispersion medium and dispersion phase. Dispersion medium and dispersion phase. Okay, what is this dispersion medium? Okay, so it is continuous phase in which continuous bulk phase in which the colloidal particles are dispersed. Colloidal particles are dispersed. That is called dispersion medium. It is a medium. Later I will explain. Okay. So dispersion phase means the particles of size 1 to 1000 nanometer, which are dispersed in dispersion medium or as dispersed phase. Okay, so listen, I will give you the example here. For example, okay, dust particle in our you take smoke. Smoke you take. Smoke nothing but smoke. So students here, dispersion medium means it is a continuous bulk phase, one which is present in bulk concentration. Among CO2 and air is the bulk concentration. So that's why this is dispersion medium. This is the medium in which the CO2 molecule gets dispersed. Dispersed means they are easily mixed up. Understand? Distributed. So this is the air. Okay? If smoke is evolved here, then it is completely distributed throughout the air, throughout the room. So that distribution is called as dispersed. Dispersed means distribution throughout the air. So this CO2, it is a dispersed phase. So listen students, easy thing you have to remember, it is simply a word dispersion medium and dispersed phase. It's nothing but a solution. But this solution type is colloid. So in the solution, you often use solute plus solvent. In solution is equal to what? Solute plus solvent. Okay? So solute is what? One which present in small quantity. Solvent means what? One which present in bulk quantity. Understand? So this one is, another one is, this is solution. Colloid. Colloid means what? One is dispersed phase plus dispersion medium. Same here. Dispersion medium means one which present in bulk manner. Dispersed phase means one which present in less quantity. Here CO2 is less quantity. This is more quantity. Means this is also nothing but solution. But here, instead of solvent, we use dispersion medium. Instead of solute, we use dispersed phase. Instead of solution, we are going to use colloids. Are you getting? So don't confuse in that. What is dispersion medium? What is dispersion phase? Solute is dispersion phase. Solvent is dispersion medium. So it is a gas solution. Understand? In the solution chapter, I already told. If the solute is gas, solvent is gas, then it is gas solution. Solid solution, solid liquid solution. You know about it. So in gas solution, smoke is the example. So here CO2 is the solute and this air is the solvent. So these two mix up together form a type of solution. That solution nothing but called as colloid. Understand? Here always the dispersion medium means solvent. Dispersed phase means solute. Remember, dispersed phase means solute. Dispersion medium means solvent, where the solute particle is dissolved or distributed. Here we cannot dissolve, they distribute. The distribution is called as what? Dispersion. Sorry, dispersion. Understand? Okay. So the next one. Types of colloids. Types of colloids. So remember, students, here in the types of colloids, three types is there. First one is based on physical state of dispersed phase and dispersion medium. Okay, based on physical state of dispersed phase and dispersion medium. So students, based on solid, liquid, gas. So based on this, they are classified as salts. Okay, solid salt. Okay, next gel, next solid foam. I'll explain later. Next, salt, emulsion, foam. Soil, emulsion, foam. And last one is solid aerosol colloid. Another one is lyophobic colloid. Understand? Lyophilic colloid and lyophobic colloid. Okay, so students, lyo means solvent, philic means love. Lyo means solvent, philic means love. Okay, so solvent loving are called as lyophilic, solvent ating are called as lyophobic. Understand? Listen here. This phobic means hate, philic means love. Lyo means solvent. Solvent loving colloids are called as lyophilic. Solvent hating colloids are called as lyophobic. Okay. Next, last one is based on nature of colloidal particles. Okay, so in the first one, multi-molecular colloid. Next, macromolecular, and the third one is associate. So based on nature of aggregation unit. Based on nature of aggregation, multimolecular, macromolecular, and associated. This is the classification. One is based on the physical state of dispersed phase and dispersion medium. They are classified as solid salt, gel, and solid foam. Based on this, if liquid is the dispersion medium. Okay. Next, salt, emulsion foam, solid, aerosol, liquid aerosol. Okay, I'll explain. Next, based on the affinity between dispersed phase and dispersion medium, two types of classification: lyophilic colloid and lyophobic colloid. Based on the nature of aggregation, aggregation means collection. Okay. Next, multimolecular, macromolecular, associated. Okay. So students, I'll explain one by one. So this is first one, based on different physical phases of dispersion medium and dispersion phase. Listen, this one is dispersion phase, this one is dispersion medium, this one is type of a colloid, this is the example. If the dispersion medium is solid, consider all are solid only. Next, liquid, 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 okay, gas, gas. Okay, if the dispersion medium is solid and dispersed phase is also solid, means solid solute is dissolved in solid solvent, like that. You know, which one is Zimpa? Sorry. In the solids we want to say means in the solution that alloys, mixture of pure metals, alloys, copper, zinc, bronze, brass, that is a uniform mixture of alloys, right? So that is homogeneous. This is heterogeneous. Understand? So dispersion medium, solvent is also a solid, solute is also a solid. So then that is called as solid salt. That is called as solid salt. Okay? If this solid dispersion medium is solid, dispersion phase is liquid, then it is called as gel. Understand? And dispersion medium, that is solvent is solid, solute is gas, then it is called as solid foam. Remember here, this is called as solid foam. Next, liquid. If the dispersion medium, nothing but solvent is liquid and this one is solid. Liquid and solid. That is simply called as salt. If solvent is liquid and solute is also liquid, then that is emulsion. Okay, so this is liquid and this one is gas. Example is foam. Okay, next, if the gas is the solvent and solid is the solute, then it is called as solid aerosol. And if it is liquid, then it is called as liquid aerosol. So students, here we cannot consider gas and gas because gas and gas mixture is a homogeneous mixture. Here the colloids are heterogeneous compounds. Understand? That's why we cannot consider gas mixture. That is a homogeneous mixture. So students, example for this is the solid is the dispersion medium, solid is the dispersion phase. The best example is glass. Okay, next, solid and liquid. Gel we want to take, so that you may like butter, cheese. Butter and cheese. And also next, this one, gas is solid. So for this you may say that is rubber, foam rubber especially, and also pumice stone. This is the example. So students, let's learn. Liquid is the solvent and solid is the solute. Liquid, solid. That is salt. They are going to ask students. They didn't ask this one. Give an example for solid salt. Give an example for a gel. Give an example for a solid foam. Give an example for salt. In the examination, they are going to ask like this. This is very important. This one and that one. Understand? So example for this salt is ink. Okay? Ink is there, paint is there. Another example for salt. Emulsion means milk, cod liver oil, milk, cream also. Cream and cod liver oil. This one and this one is, remember, they are going to ask, give an example for salt. Okay? Next, foam means that is shaving cream, it is shaving cream and soda water. Even like give example here. So liquid gas. So soda water means in that water CO2 gas is compressed. Soda water means CO2 gas is liberated, you know. Here liquid means that water. That soda water formed by what? Dispersion of this CO2 gas. Means cold drinks na use ಮಾಡ್ತೀವಲ್ವಾ 7 up ಆಗಿರ್ಬೋದು ಆಗಿರ್ಬೋದು ಅದನ್ನ ಶೇಕ್ ಮಾಡಿದಾಗ ನಿಮಗೆ CO2 ಗ್ಯಾಸ್ ಲಿಬರೇಟ್ ಆಗುತ್ತೆ ಗ್ಯಾಸ್ ಹೊರಗಡೆ ಬರುತ್ತೆ ಬಬಲ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ that is what example for this foam shaving cream and also soda water. Okay, so the next one is gas and solid means example is dust, soot, etc. Okay, next this fog and mist. These are the examples for this type of sounds. Understand? Any doubt? Here nothing is done. You have to remember this one because they already clearly mentioned. Of course, these are called as solids. These are called as solid salts, gel, solid foams, all because of their properties. You have to memorize this. Understand? This and this. Example and also type of the solids. So this is what first type of classification based on physical state of dispersed phase. Understand? Okay. So the next we will go with the second classification that is based on affinity towards the dispersion medium. That is second type affinity towards affinity towards dispersion medium. DM means dispersion medium. Remember, I won't write it again and again. Okay. So students here, okay, this dispersion medium, one is I'll say lyophilic. Okay. So another one is lyophobic. So students, lyophilic and lyophobic are the Greek words. Lyo means solvent, philic means loving. So this phobic means hating. Okay, the solvent loving colloids are called as lyophilic. The solvent hating colloids are called as lyophobic. Understand? So here, okay. So how you have to write the solute have affinity towards solvent. That is written in the form of surface chemistry. In the surface chemistry, solute particles means dispersed phase. Solvent particles means dispersion medium. So in salts or in colloids, okay, in colloids, the solute, that means dispersed phase, as affinity towards solvent, that means dispersion medium. This is the exact definition. Okay, the solute particles have the affinity towards solvent, that is written as in colloids the dispersed phase as affinity towards dispersion medium, called as lyophilic colloids. So here exactly opposite. In colloids, the dispersed phase do not have affinity towards dispersion medium. Do not have affinity towards dispersion medium. Okay, so students, example for this is starch, cellulose. Okay, starch, cellulose, albumin, and protein in water. Protein in water. Okay. Next. So for this example, ferric hydroxide in water. Ferric hydroxide in water. Or first one, second one, sulfur in water. Understand? So students, listen here. These are affinity towards water. Of course, they easily dissolve in water. These, they do not have affinity towards water. Here, if they dissolve in water, okay, or any solvent. Not I am telling it. Of course, this is example for water. Assume starch is dissolved in water. If it is dissolved in water, we can reverse it. This process is reversible. How? When it is dissolved in water, if we give the temperature, all the water evaporates. When all the water evaporates, these crystallites, these colloids, which are not exactly dissolved in the solution, are easily obtained in the form of a solvent. Understand? For example, any salt is there, too much salt is dissolved in water. If all the water is evaporated, then salt residue is left in the container, right? Similarly, in the same way, if the complete solvent is evaporated by giving the temperature, of course, this will left as a residue. So this reaction is reversible, but this reaction is irreversible. Understand? So ferric hydroxide in water. They are not mixed up with water. They are water 18, not water 18, solvent 18. Understand? The 18 means they are not form any strong colloids with them. The bond between them is not strong. They are 18. Understand? So we can easily separate them. Understand? So it is a reversible process. They are already separate in the solution or separate in the colloids. Understand? So this is all about lyophilic and lyophobic. Lyophilic and lyophobic. This is the definition. This is the example. This is very important for 2 marks. Another one is the difference between lyophilic salt and lyophobic salt. So students, listen here. These are hydrated, but these are not hydrated. These are heavily hydrated. They are always associated with water molecule, but these are not associated with water molecule because water is a solvent. These are all solvent aiding species. Understand? And next, okay, here the particles cannot easily detectable. Why? Because the love the solvent molecules means they easily dispersed in them. But here they can easily detectable, means at least in the microscope we can detect them. Understand? So this is the differences. In the tomorrow's class I will explain the difference. Remember, this is lyophilic and this is lyophilic, which is phobic, which is important for phobics. Understand? Thank you.